When we want to identify which quadrant contains the terminal side of each position angle, we have to remember what a position angle is. And that's just an angle in standard position, meaning the vertex is going to be at the origin, and the initial side is on the positive x-axis. So then the terminal side is going to be rotated away from that. To identify where 212 is, we use our axes, the x and the y axes, to remind us of a few checkpoints. Like as we go around the circle and we get to the positive y-axis, that's at 90 degrees. Continuing over to the negative x-axis, that's 180 degrees. The negative y-axis is 270 degrees. And when we complete the circle, then we're back at 360 degrees. So where is 212? Well, as we go around the circle, it's going to have to be past 180 degrees, but before 270 degrees. So about right here. This angle would be our 212 degree angle, putting it squarely in the third quadrant. If you're wondering about which quadrants are which, as we rotate around this circle, each quadrant that we come along is numbered with Roman numerals. So the upper right quadrant is the first quadrant, the upper left quadrant is the second, the bottom left is the third, and the bottom right is the fourth. So let's continue with our 12 degree angle. We'll start at the positive x-axis and rotate up 12 degrees. That's only going to be a little bit because we won't even get to the 90 degree mark. It's going to be about right here, 12 degrees. There's that 12 degree angle, putting the terminal side in the first quadrant. And then for our -1 degree, when we go a negative degree measure, that means we're going to rotate down instead of rotating up. So if we go down just 1 degree, we'll rotate this way. That's where our -1 degree is, putting that in the fourth quadrant. When we're in radians, the position angle is still the same, that we have our vertex is at the origin, our initial side is the positive x-axis, and we're going to rotate the terminal side around from there. But when we're in radians, we want those checkpoints to be in radians as well. So thinking about going all the way around the circle, we know there's 2 pi radians in a circle, so if we go halfway, we're at pi. Halfway between 0 and pi would be pi over 2. And halfway between pi and 2 pi would be 1.5 pi, or 3 pi over 2. So when we're looking at 2 pi over 3, where is that? All right, remember that this pi is our 180 degrees. When we do pi over 3, we're literally going to take this top half of our circle and divide it into 3 equal sections, which would be about here and here. So it kind of makes 3 little pi pieces here that are each the same size. Right? Each one of them is 1 pi over 3. We want 2 pi over 3. So here's our first pi over 3, and our second pi over 3 is going to be this angle right here. So which quadrant is that in? That's in the second quadrant. For 11 pi over 10, let's see, 11 tenths, that's a little bit more than 1. 1 pi is at 180 degrees, so that would be 10 pi over 10, because 10 divided by 10 is 1. If we want 11 pi over 10, we need to go another tenth of a pi. So just a little bit. Here's that 11 pi over 10 angle, putting it in the third quadrant. And finally, 3 pi over 4. So going back to our pi angle, our top half of the circle, if we divided that into fourths, right, we know pi over 2 is here, so cutting that in half would be a fourth. Cutting it in half over here would be a fourth, and we see we have these 4 pi pieces that are equal in size, and of course we want 3 of them. So 1, 2, 3 puts our terminal side right here. This being angle 3 pi over 4. So that terminal side is in the second quadrant.